Okay, here we are given that if the pressure 23 meter below a liquid is 338.445 kilopascal, determine its unit weight, gamma, mass density rho, and its specific gravity s. So here we just want to know what are the given and to make things simple. Now of course we know that 23 will be h, the depth. So h will be 23 meters. Okay, you'll put meters here. 23 meters. Here, meters. Okay. I also given with pressure equal to 330, 338.445 kilopascal. And here in fluid mechanics, if we are not given its gauge, if you are not explicitly given that it is, shall we say, absolute pressure, then it is assumed to be gauge pressure. So yung nga na ang idea. By default, if the pressure is not really stated to be absolute, then it is a gauge pressure. Now, that's pressure, and here we are just required to determine what is the mga required. Now that's our given. Our required will be unit weight, mass density rho, and a specific gravity s. So here this will really just be a simple equation, and this is really barely familiarization on what is the idea, what is the definition of weight, unit weight, mass density, and a specific gravity. So now, well, we are actually very familiar with mass density. This is what we usually use, this mass per unit volume. So this is what we'll be able to solve first. Using the simple equation that P, the pressure as you go deeper will increase by rho GH. So in this case, we know that the pressure is 338, but here we convert that to Pascal. So how do you convert kilopascal to Pascal? You multiply by 1,000. So that's 338 times 0.445 times 1,000. That's 338,445. Now that will be equal to rho of the fluid times G, which is 9.81, times H, which is the depth, which is 23 meters. So as you can see, I don't put units because it will just make the computation longer, and I don't want to really write much, but as long as you're confident that you're using standard SI units, then you'll be safe. Now here rho will then therefore be equal to certain value, and that rho is 1,500. So here the rho is 1,500 kilogram per m cube. So that's standard SI units for density. Now, how about this other required gamma and a specific gravity? Now, when this is simply mass density, this is just equivalent to mass of the fluid or the liquid divided by its volume per unit volume. When we say gamma, it's simply equal to the weight. Okay, when we say gamma, it's simply equal to the weight of the fluid, weight over its volume. Now, if we know rho, how do we get gamma? Well, since rho is mass per unit volume, we're looking here for weight per unit volume. How do we get weight if you're given with mass? We simply multiply here mass per unit volume by G, which is mass times G is weight, and it also follows that will just simply be equal to rho times G. So that's gamma simply rho times G, and in this case, the rho is 1,500. So allow me to write units here to make things simpler. 1,500 kilogram per m cube. Multiply that by G, which is in our case 9.81. So I would like to write here kind of equivalent, so that people will not think, oh, it's multiplied to mass over volume. Now, 9.81 meter per second squared, and here kilogram meter per second squared is simply really Newton, or the weight. So Newton per m cube ang unit. So the answer will simply be 14,715. 14,000. So I'll write here 14,715. The unit, of course, is Newton per cubic meter or per m cube. So that's raw. And how about what is a third na question? S specific gravity, S, or it could be SG, but I prefer to write SG instead of S. So SG is simply the ratio of, it's simply a measure of how heavy it is compared to standard liquid, which is of course water. So simply raw of the fluid, raw of the liquid that we're talking about, over raw of standard water at 4 degrees Celsius. So in our case, this will be raw of the liquid is ang atong raw 1,500, and here raw of water is 1,000. Simply that will just give us Sg to be equal to, or S in our case really, 1.5. So these are our answers. Sg 1.5. It will be unitless, meaning unit cancels, and here gamma will be 14,715, and here density will be 1,500. It will be a good practice to box out box in your final answers so that you'll really see kung imong final answer dyan. So I think that's it.